Hello everyone, welcome to NEET mock test series brought to you by Toppscholars, the smart learning app. Today in this lecture, we are going to see the mock test analysis for physics. In a coil of resistance 10 ohm, the current induced by changing magnetic flux through it is shown in the figure as a function of time. Okay, the magnitude of change in flux through the coil in Weber is what? So here you can see we have got current on one side and time on the other axis, and this is the graph of how current is changing with respect to time. Okay, so here we can see this is 4 and this is 0.1. Okay, now options are 6, 4, 8 and 2. Okay, so these are the options. What we have to find out is the magnitude of change in flux through the coil in Weber. Okay, this is what we want to find out. So over here few things are given, like the resistance is given. Okay, so we can find out the change in flux. So let's look at the solution. Here it is. This is the diagram. Then we know EMF is equal to I into R. This is the standard formula. Therefore, I is equal to EMF upon R. Okay, but EMF is equal to this formula also, that is d phi by dt, and it is equal to I into R, and therefore d phi is equal to R into I into dt, isn't it? From this equation you can see, if we take the dt on the other side, then d phi, the change in flux, is equal to R into I into dt, and therefore phi, if we want the phi, we have to integrate this d phi. Integration d phi will be equal to R is constant, it will come out integration I into dt, and therefore integration I dt over here is nothing but the area under the curve equal to area of the right angle triangle. Okay, area of the right angle triangle. Here you can see the curve is a straight line right now. Okay, the graph shows a straight line. So if we want the integration I dt, then it should be nothing but the area of this graph. Okay, area under this graph. So we can easily find out this because it's a right angle triangle. So the area of the right angle triangle can be easily found out with a standard formula, isn't it? So integration I dt is equal to 1/2 into 4 into 0.1. Okay, we know that the area of a right angle triangle is nothing but 1/2 height into base, isn't it? So therefore we have put the same numbers. 1/2 height is 4, then this is the base, that is 0.1, it is equal to 0.2. Okay, so this is the integration. Okay, and therefore phi will be equal to R into 0.2, and R is nothing but 10. 10 into 0.2 is 2 Weber. So the change in flux is nothing but 2 Weber. Okay, so therefore the correct answer is going to be option D, that is 2. Okay, 2 is the correct answer. A proton carrying 1 mega electron volt kinetic energy is moving in a circular path of radius r in uniform magnetic field. Okay, so r is the radius. What should be the energy of an alpha particle to describe a circle of same radius in the same field? Okay, so first there is a proton carrying energy 1 mega electron volt, and then we have an alpha particle. Okay, so what should be the energy of the alpha particle? That is what we have to find out. Options are 0.5 mega electron volt, 4 mega electron volt, 2 mega electron volt, and then 1 mega electron volt. Okay, so let's look at the solution. When a charged particle carrying charge q and mass m is projected in a uniform magnetic field B with velocity v, then it experiences a magnetic force. Okay, due to this force, it starts to move in a circular path. Okay, the required centripetal force is provided by the magnetic force actually, because we know for any particle to perform circular motions, there has to be some centripetal force, and in this case it is provided by the magnetic force only. Okay, centripetal force is equal to magnetic force, and the standard formula for centripetal force is mv squared upon r, and magnetic force on any charge is given as qvb. Okay, Q is the charge, V is the velocity, and B is the magnetic field. Okay, then from here we can say R is equal to M upon QB into V, isn't it? We have just arranged this equation. We can see this V and over here one V cancels, and after arranging we get R equal to this equation. Okay. Now let's say that K is the kinetic energy, and kinetic energy is nothing but 1/2 mv squared. Okay. This is the standard formula as we all know. Okay. Now over here, from that equation of kinetic energy, we can write V square is equal to 2k upon m, and therefore V is equal to under root 2k upon m. And therefore, after putting this value of V, okay, this V in the equation of radius r, it will be m upon qb under root 2k upon m, because if you remember, this formula was mv upon qb. Okay, so we have just put the value of this V over here. Okay, now what we have done is we have taken this m into this roots, so we have to make it squared, and therefore this m and this m will cancel and only one m will remain over there, and therefore under root 2 mk upon qb, that is going to be the radius. And now what we can do is we can just arrange this. What we will do over here is we will square this whole equation. After squaring, what we get is k equal to qrb whole squared upon 2m. What we have done over here is we have squared this r squared equal to, this root will be gone, 2mk upon qb whole squared, and we have taken this on the other side, then taken this 2m on the other side in the denominator, and what we get is the value of k, that is kinetic energy. Okay. Now for a proton we can write over here Kp, the kinetic energy of the proton, it is equal to ERB. You can see it was QRB, but what we have done is we have put the value of Q, because we know that proton is positively charged with the charge equal to E, that is 1.6 into 10 raised to minus 19 coulomb, but it's positive. Okay, and m is equal to mp for proton, that is mass of proton. So we have just put the values for proton over here, and this is the kinetic energy. Okay, now similarly for an alpha particle which has a mass 4 times the mass of proton and twice the charge, we can write over here this equation, k alpha is equal to 2e. Here you can see instead of just 1e we have put 2e because it has got twice the charge, 2e rb whole squared upon 2 4 mp. Okay, 4 times mp because it has got mass 4 times. Okay, and after arranging this and cancelling out few terms, what we get is this ERB whole squared upon 2 mp. Okay, now dividing 2 by 1. Okay, so if we divide this equation by that previous equation for the proton, what we get is this, we get 1 only. That means what? K alpha is equal to Kp. Kinetic energy of alpha should be equal to kinetic energy of proton, and it is 1 mega electron volt, that is given over here. Okay, so therefore the correct answer in this question is going to be option D, that is 1 mega electron volt. Okay, so that's the correct answer. So here is another question. A cell having an EMF E and internal resistance small r is connected across a variable resistance capital R. Okay, as the resistance R is increased, the plot of potential difference V across R is given by which one of these? So here we have some options, option A, option B, then option C, and then option D. Okay, so we have to identify which one of these plots are the correct plots for the potential difference V across R in this case as we increase R. Okay, so let's find out. It's very simple. Okay, first of all, we know the potential difference, okay, across the resistor R can be given as this one. Here you can see V is equal to E minus IR, where E is nothing but the EMF of the battery, I is the current flowing through the circuit, and small r is the internal resistance. Okay, so it is equal to ER upon R plus R. After solving this equation, after putting the values of I and everything, we get this equation finally, and after solving and arranging this equation, we get E upon 1 plus small r upon capital R. So, we have got the value for V, that is this equation. Now, we have to find out how this V varies with respect to capital R. Okay. So, it's very simple. You can see over here, when this R is equal to 0, then V will be equal to 0. You can check here. If we put 0 over here, then small r upon 0 is going to be infinity, then 1 plus infinity will be infinity, then E upon infinity is going to be 0, therefore, V will be equal to 0. And if R is equal to infinity, you can put infinity over here, R upon infinity is going to be 0, 1 plus 0 is 1, and E upon 1 is going to be E. So, therefore, V is equal to E. Okay. So, that is why we can see over here, initially when R is equal to 0, V is going to be equal to 0, and as you increase this R towards infinite value, then this V will tend towards E, that is EMF of the battery. Okay. So, therefore, the correct answer, the correct graph would be this one. You can see here, this is the y-axis showing voltage, and here we have R, the resistance. As we increase R towards infinity, then you can see voltage is increasing, but it will never cross this EMF. It will eventually tend towards the value of EMF. Okay. So, that is what is happening over here. So, therefore, this is going to be the correct plot. Okay. So, therefore, the correct answer over here is going to be option A. Okay. So, this is the correct one. So, here is another question. For the angle of minimum deviation of a prism to be equal to its refracting angle, okay, the prism must be made of a material whose refractive index what? So, there is a question mark. Again, for the angle of minimum deviation of a prism to be equal to its refracting angle, okay, the prism must be made of a material whose refractive index is what? So, options are, is less than 1, is greater than 2, lies between root 2 and 1, lies between 2 and root 2. So, definitely this is not the answer, because refractive index cannot be less than 1, we all know, but which one of these three is the correct answers? Okay, let's find out. It's very simple. Here we can see the diagram. This is the refracting angle, or we can call this as angle of prism A. Okay. Now, what we want is the angle of minimum deviation, okay, of the prism to be equal to its refracting angle. Okay. Now, first of all, angle of minimum deviation of a prism is the angle of incidence at which the deviation of the incident rays of light is minimum. Okay. So, this angle of minimum deviation is nothing but the angle of incidence, okay, at which the deviation is minimum. So, what we will do over here is, we will put this angle of incidence equal to A, that is angle of prism. Okay. Now, what happens is, let the angle of incidence is equal to the angle of minimum deviation. As we have said, the refractive index of the material of prism in terms of the angle of minimum deviation is given by this formula, mu equal to sine A plus delta m upon 2 divided by sine A by 2, where delta m is nothing but the angle of minimum deviation. Okay. So, what we will do, we will put delta m equal to A. Okay. So, after putting this, what we get is something like this. Okay. So, over here we get sine A upon sine A by 2. Okay. And we can write this as sine 2 times A by 2 upon sine A by 2, and this sine 2 A by 2 can be written as sine 2 sine A by 2 cos A by 2. Okay. This is how we have expanded this. This is a standard trigonometric equation. Okay. Sine 2 theta is equal to 2 sine theta cos theta. So, therefore, 2 sine A by 2 cos A by 2 divided by sine A by 2 as it is, and this cancels, and what we get finally is mu equal to 2 cos A by 2. So, we have got an equation for the refractive index mu over here. Okay. Now, the question that has been asked is something like this. We have to find out the refractive index. Okay, what is the value or what is the range of refractive index such that the angle of minimum deviation is equal to the refracting angle. So already we have put the angle of minimum deviation equal to the refracting angle. Now we have to just find out the conditions from this equation. Okay, so we know the values of A can vary between 0 and 90 degree, isn't it? Because angle of incidence can be 0 to 90 degree, isn't it? It cannot be greater than that. Okay, so therefore let's find out the minimum first. Mu minimum will be equal to 2 cos 90 by 2. Okay, because we know for 90 degree we are going to get the minimum value of cos. Okay, and for 0 degree we are going to get the maximum value for cos function, because we know cos 0 is 1 and cos 90 is 0. Okay, therefore for minimum value of mu we have to put this A equal to 90 degree, and for maximum value we have to put this A equal to 0. Okay, so first mu minimum is equal to 2 cos here 90 upon 2, and after solving we get this root 2. We are getting how much? Root 2. Okay, and this mu max is going to be equal to 2 cos 0, isn't it? 2 cos 0. Here we have put the value A equal to 0. So cos 0 is 1, and therefore we are going to get only 2, isn't it? So here we can see mu minimum is root 2 and mu max is 2. Okay, so this is the condition that we are looking for, isn't it? So therefore the correct answer over here is going to be this one. Refractive index lies between 2 and root 2. Okay, so this one is the correct answer. So here is another question. A slab of stone of area 0.36 meter squared and thickness 0.1 meter is exposed on the lower surface to steam at 100 degrees Celsius. A block of ice at 0 degrees Celsius rests on the upper surface of the slab. In 1 hour, 4.8 kg of ice is melted. The thermal conductivity of slab is what? Given latent heat of fusion of ice is this 3.36 into 10 raised to 5 joules per kg. Okay, so we have to find out what? Thermal conductivity of the given slab. Okay, options are 2.05, okay, joules per meters per seconds per degree Celsius, then 1.02, then 1.24, then 1.29. Okay, so we have to find out this correct answer. The situation is something like this. We have a slab over here, okay, and this slab is actually exposed to some steams, okay, from below. Okay, there are some steams at 100 degrees Celsius, okay, and the upper surface over here, on the upper surface we have kept ice. Okay, so what happens is these steams are definitely hot, having higher temperature, that is 100 degrees Celsius. Okay, therefore this lower surface of the slab is going to be heated, and this heat is going to be transferred to the upper surface slowly depending on what is the thermal conductivity of this given slab. Okay, so because of this heat transfer, this ice is slowly going to melt, and it has been given that in 1 hour 4.8 kg of ice has been melted. Okay, so what is the thermal conductivity K for this material? That is what we have to find out. Okay, so let's do this. Here it is. We know the amount of heat transferred per unit time is given as this equation. Here it is, delta Q upon delta T, that means amount of heat transferred per unit time is equal to Ka T2 minus T1 upon delta X, where K over here is what? The thermal conductivity, A is the area of the slab, then T2 minus T1 is the definitely the temperature differences, and delta X is nothing but a distance between the two ends. Okay, so but the heat added to the ice is delta Q, that is ml, isn't it? M is the mass and L is the latent heat. Okay, so we can find out this. Here it is. We have put delta Q equal to ml upon delta T as it is. Okay, then after arranging this equation, we get K equal to ml delta X upon delta T into T2 minus T1 into E. Okay, you can check this. We have just arranged this equation. Okay, now what we will do is we will just put the numbers. Okay, M, it has been given 4.8 kg of ice has been melted. Okay, then over here, this is 3.36 into 10 raised to 5, that is the value of L, that is latent heat. Okay, then delta X is just 0.1. Okay, because here you can see thickness is given, that is 0.1 meters, and then divided by time is 1 hour, that is given, so we don't need to put it. Okay, over here, but we have to convert this one in seconds. So that's why we have converted this to seconds, that is 3600, and this T2 minus T1, that is the temperature difference, is 100 degrees Celsius. If you convert this, you are going to get 100 Kelvin. Okay, and then area is also given, that is 0.36 meters square. Okay, so we have put all the numbers, and after calculating, finally we get to this number, that is 1.24. Okay, 1.24 joules per meters per seconds per degree Celsius. Okay, so this is going to be the correct answer for this question. Okay, option C is the correct answer, 1.24.